Hi everybody. Today we are going to be continuing on our trig journey, and we're going to be talking about two new things. That's the angle of elevation and the angle of depression. So the angle of elevation probably sounds exactly what it means. It's the angle at which we look up at something. So in our picture here, you can see Billy is looking up at those balloons, and the angle that's created between his horizontal neutral line of sight. So when you're normally just kind of looking around, you're looking straight ahead. That's your neutral line of sight. So we're going to call that the horizontal. And then when you look up at something, that is now your line of sight. So Billy's looking up at the balloons, so his line of sight is this dashed line. And the angle that's created between that horizontal and your line of sight looking up is called your angle of elevation. So angle of elevation is the angle at which you look up. Now, what's really important about this is your angle of elevation and the angle of depression, when we get to that in a minute, are always formed between the horizontal. That's really important. The horizontal and the thing that you're looking at. So between the horizontal and your line of sight. So it's formed between the horizontal. I would honestly underline, box, star. It's got to be between the horizontal and the line of sight. All right, so horizontal, what we're looking at, if we're looking up, it's angle of elevation. So the word elevate, elevator, those are things that take you up, looking up, moving up. So that is our angle at which we look up. All right, so let's use that information to do a word problem here. So angle of elevation and depression really kind of lend us to the whole word problem thing. So Jake is tired of holding a kite string, so he tacks it to the ground. So I'm sure you've all been outside and it's so windy and you've been flying your kite and it's been awesome, but now you're tired. But you don't want to reel it in quite yet because the wind is still so good. So Jake is going to tack it to the ground and relax a little bit. All right, so here's our kite. We've got our kite string that Jake has tacked to the ground. Oh, I can't draw a straight line to save my life, but you understand what I mean, right? All right, so this is the ground. Here's our string. And then this right here, this vertical line is going to represent the height of our kite, which is what we're going to be looking for. And then Jim was tired, so he's taking a little snooze. Got his hands behind his head, relaxing. All right, so Jake is tired of holding the kite string, got it, tacked it to the ground, got it. He lets out all 50 feet of string. So you don't have to draw a picture with like details in it, but I find that it's really helpful when I'm trying to figure out where my numbers are going to go in the picture if I actually have details. So I don't just have a right triangle, I have a kite. I can see that the kite, I've labeled it string. Again, you don't have to label, but it does make it easier for me personally to like know where my numbers go. All right, so string, that's 50 feet. The angle with the ground. So that means the angle that's formed between the string and the ground. So this right here. Now, since the ground is typically horizontal and our string is going up to the kite, that means this 35-degree angle is actually our angle of elevation. From the horizontal up to the thing that we're looking at, or in this case, the thing that we're attached to, that is our angle of elevation. Now, don't forget that height is always going to be perpendicular to your base. So the base is the ground, so the height would be perpendicular, which creates this right triangle, which means now we can use trigonometry to find the height. So pause the video, take a second, and see if you can set up this trig function and find out how high the kite is. All right, so while you were paused, I added a couple things to my picture. I labeled my sides opposite, adjacent, and hypotenuse. The height is opposite of our angle of elevation. Our hypotenuse is our string. So thinking about SOHCAHTOA, since I'm looking for the height, the two sides that are going to help me are opposite and hypotenuse. So we're going to choose the sine function. So the sine of 35 degrees is equal to opposite, which I'll just call x, over hypotenuse. And now we're just going to take a second and solve this. So we're going to multiply both sides by 50 to get that 50 out of the denominator. So x is going to equal 50 times the sine of 35, which means our height is equal to 28.7. So 28.67 is going to round to 28.7, and then what were our units? Feet. There we go. All right, let's take a look at our next one. So this one, I mean, it's pretty, there's all the information's on a picture. How tall is the building? That's all we need to figure out. So X is representing the height of the building. What is the 20 representing? Looks like 20 is representing, I'm going to call this guy Bob. 20 is representing how far Bob is away from our building. The 6 feet is representing how tall Bob is. And 67 degrees is representing our angle of elevation, because it's from the horizontal, his normal neutral line of sight, up to the top of the building. All right, so if we want to find out how tall the building is, do you notice that the right triangle that is formed right here, this side is not representing the full height of the building? So if we find that side, we don't know X. What do we know? We know how far it is from Bob's eye up to the top of the building. So when we want to find X, we're going to have to add in how tall Bob is, this little piece. So I'm going to actually call this side Y. So I know that when I find it, it's not the full height of the building. It's the building minus how tall Bob is. All right, so if we call that Y, I want you to take a minute, pause the video, set up a trig function for Y, and see what you come up with. All right, so in our picture, Bob is 20 feet away from the building, so that 20 can be moved right up to the bottom of that triangle. So Y is our opposite side. The 20, which we know, is our adjacent side, which means if we look at SOHCAHTOA, we're going to be using the tangent function. So the tangent of 67 equals Y over 20. Multiply both sides by 20 to get that 20 out of the denominator. So Y is going to equal 20 times the tangent of 67. So Y is equal to 47.1 feet. There's our units. Now don't forget that this is not the height of the building. So for our height, we are going to use Y plus the 6 feet, right? So it's this whole distance plus how tall Bob was. So that means our height is going to equal 53.1 feet. So 67 degrees was our angle of elevation because it was the horizontal up to the top of the building. And then from there, we just use a traditional trig function. All right, so like I said, angle of elevation is pretty self-explanatory. Angle of depression is kind of like the opposite. So the angle of depression is the angle at which you look down at something. Now, if you'll notice from our picture, the angle of depression is still, just like up here in the angle of elevation, is still formed between the horizontal and your line of sight. So this time Bob was in a hot air balloon. He was just looking out at the horizon. Oh, it's so pretty. And then he spots a pot of gold. Oh my gosh, of all things. So when Bob looks from his normal neutral line of sight, the horizontal, down to that new thing, the angle of depression is formed. So still always formed with the horizontal. So that part is really, really important. So then where is our right triangle? Well, we have a couple options here. So our first right triangle, we could just do this. So this distance right here is still representing the height, the distance between what's on the ground or what's below you up to where you are. But our other option is actually making a right triangle right here. and using this blue guy as our right triangle, which a lot of people are more comfortable with because when you find height, normally you go directly below the thing. Instead of it being over here, a lot of people are more comfortable with it over here, which is totally fine. This blue triangle is actually congruent to that triangle over there. So there's our right angle, here's our right angle. This line of sight is the same, right? And this horizontal distance is the same. And in a right triangle, that would be hypotenuse leg. So we can actually actually prove that those two triangles are congruent. Now, here's the tricky part. If you draw your triangle underneath, right? If you draw your triangle in this blue triangle, this right here, this angle is not the angle of depression. This is where most people tend to make a mistake. This is not your angle of depression, because what is your angle of depression made between? The horizontal and the line of sight. And this blue guy right here is a vertical line, so that cannot form your angle of depression. So if you have the angle of depression, if they tell you the angle of depression is like 25 degrees and you don't draw your triangle here, then what do? Like, where do you put your angle? Well, you have a couple options. If you know your angle of depression here, let's say it's 25, then this would also be 90 degrees. So you can just find the complement to your angle of depression. So this would be the complement to the angle of depression. Now, the other awesome thing that you could do, though, is we're going to flash back to semester 1. This horizontal line and the ground, this horizontal line, are parallel. This dashed line of sight is a transversal, which means the angle of depression and this angle right here, which would be an angle of elevation, wouldn't it? Horizontal looking up. The angle of depression and your angle of elevation are congruent to each other, alternate interior angles. So if you know this is 25, but you really like this triangle instead of this one up here, then you would put your angle of elevation here, and it's congruent to the angle of depression. So you have a couple options. What you choose to do is up to you. All right, we'll use that in just a second. I just have one more visual for you. So instead of them being individual triangles, just another visual. If you are right here, your horizontal neutral line of sight here, you look up, it's the angle of elevation. You look down, it's the angle of depression. All right, so let's look at example 3. Ranger Jim spots a forest fire from a 50-foot high tower. Again, you don't have to draw a picture to go with it. First of all, it's kind of fun. Instead of always just drawing triangles, like, put a little creativity in your pictures. All right, so our tower is 50 feet high. Here's Ranger Jim hanging out. He sees a fire and the angle of depression from Jim to the fire is 38 degrees. So angle of depression. So Jim was looking here straight out, and then he looked down at the fire. So in this picture, this guy right here is your angle of depression. So the 38 degrees will go here. So as much as you're going to want to put it here, this is not your angle of depression. You can put the complement of the angle of depression here. So this could be the complement of angle of depression, but it is not the angle of depression itself. All right, so again, you have a couple choices. So if this is 38, you could do the complement, or if this guy is 38, your angle of elevation would also be 38 degrees because they're alternate interior angles. So when you look up at something, it's the same as them looking down at you. That's why those two angles are going to be the same. And what are we looking for? How far is the base of Jim's tower away from the fire? So we're looking for that side right there. So for those of you who just like the simple triangle picture, your picture will end up looking something like this if you use your angle of elevation instead of your angle of depression. All right, pause the video, find X, find how far away the fire is. All right, I did a little work. You can see that I chose to label opposite, adjacent, hypotenuse. From my 38 degrees, I'm going to use opposite and adjacent, so tangent of 38 equals opposite over adjacent, 50 over x. So when I go to solve this, multiply both sides by x, divide both sides by the tangent of 38. That puts me here, 50 divided by tangent of 38. So x in this case is going to equal 63.997. So we're going to round that up to 64.0. Don't forget your units. Feet. All right, last one. An airplane is 31,000 feet above the ground and it's nearing the airport. Airplane. Nearing the airport. I don't know what airports look like. There's usually some kind of tower or something, isn't there? The angle of descent, so that's going to be our angle of depression, must be 3 degrees. So airplane's flying straight. It needs to go down to the airport. This angle right here, our angle of descent, our angle of depression, needs to be 3 degrees. How far away from the airport must the pilot start the descent? So we're actually looking for where our plane needs to be. How far away does the plane need to be to start descending? So we're looking for X right there. So go ahead, pause the video, see what you can come up with. All right, you'll see that I added a few things to my picture. I added my 31,000 feet, how far above the ground it was. I labeled my sides opposite, adjacent, hypotenuse. So based on what I have, I'm going to use the tangent function. You'll actually find that you use the tangent function a lot when you are talking about real world problems, because those are the things that usually you can measure the most. So you can usually figure out how far above the ground something is, or maybe you want to know how far above the ground something is, what its height is. But one thing we can definitely measure is we can measure how far away we are from something. Like we have tape measures, we can walk it out, how many paces away we are. So that's something that we can always find. And your angle measurement is usually something that you can find too. Did you actually know there are apps on your phone that can help, well, you have to download them, but that can actually help you find those angle measurements. So I've labeled my sides. We're going to use the tangent again. So tangent 31,000 opposite over adjacent. So we're going to multiply both sides by x to get x out of the denominator, and then we're going to divide both sides by the tangent of 3. So this is what's going to get typed into our calculator, 31,000 divided by the tangent of 3. So that's going to be x equals, which is representing how far away we are, 59,000. Nope, just kidding. 515.2 feet away from the airport. So why is that number so huge? Well, it's because our angle of depression is only 3 degrees. So I didn't draw my picture to any kind of scale, but if now that we know how far away we have to be, look at how big that is compared to 31,000. So if we wanted a 3-degree angle, this would have to be really long compared to that guy. Oh, this is not going to be good. Oh, terrible triangle. But do you see how this angle right here gets really skinny because the distance away from it is so much longer? So because our angle of depression was really small, that means the comparison of the height, the opposite and the adjacent sides have to be 3 degrees. All right, if you have any questions, please reach out to Miss Regal or myself. We'd love to help you out. Otherwise, have a fantastic day.